Well, hello again. Now we are going to start this webinar, today's webinar. So first of all, I'm going to introduce myself. My name is David Blanco. I'm a MEP engineer from the Technical Support Department of CYPE. Thank you very much for your attendance today to this webinar. We are, as you already know, we are just developing a series of webinars in order to introduce to our Open BIM technology. So the last weeks we have been introducing the presentation of the workflow with IFC Builder and other BIM modelers. Also the HVAC Open BIM systems with the thermal loads calculations and demand of energy consumption, etc. So today we are moving on in this series of webinars, and we are going to introduce our site plumbing solutions. Okay, so this is the water systems and sanitary systems solutions of our company. So for those of you with who don't know who doesn't know us, we are CYP is a software development company specialized in architectural engineering and construction software. We are developers and distributor of software, of this software. We have been over more than 35 years in the market, and we are specialized in not only for structures, MEP, management, architecture solutions for in the project phase design of buildings. We have presence in more than 60, 70 countries all over the world. We have more than 85,000 clients or customers worldwide, and we have sold for the moment more than 100,000 tools for now. So first of all, I'm just normally I start with this image with this workflow. For us, we are betting for the Open BIM technology, and this workflow implies different points. So first of all, in this Open BIM technology, we are going to start always with a physical 3D model. We are going to generate this 3D model with any BIM modelers of the market, ArchiCAD, Allplan, Revit, or another Bentley, etc., another modelers, or even our modelers, IFC Builder, for example. We are going to generate this 3D model, architectural and dimensional model, in our platform. We have developed a BIM Center platform, cloud-based solution in order to manage all our BIM projects, and also in order to collaborate with other people, all the team members of our project design. Okay. So this information of the 3D model is going to be stored in the platform, and we are going to communicate with all our Open BIM tools for the different solutions, structures, MEP, management, architectural solutions. We are going to analyze and calculate wherever specialties in the project design phase, and we are going to update the BIM model, consolidate the BIM model in order to generate the results in the platform. Also, we are going to be linked in real time, wherever time you are going to collaborate with the team members of the project. Everyone is going to be updated with a physical 3D model in real time with the different tools. Also, these specialized applications are going to be able to generate technical documents like drawings, cost estimatings, specifications, diagrams, reports, etc. So this is the idea of CYPE, of our company, to develop an Open BIM technology. This is, in order to summarize, is a collaborative, multidisciplinary and multi-user technology, which implies different softwares. And this platform, BIM Center platform, we have been developing for the recent years. So next step, we are going to explain a little bit the platform, BIM Center platform. As you can see here, you can access, or you can search in Google, or you can directly introduce the website, BIM Center. It's a free platform. Well, we have payment modalities, but in order to start, it's enough to start with a free modality. You have in plenty of space, plenty of projects, and plenty of a number of collaborators and team members. So you have to log in, you have to create an account, a free account. It's only required an email, only an email. You can register, and here in the login process, you can register here. It's only required for you only an email, and you can register and create an account. All of the team members of your company. So I have also my account here. I'm going to access now because obviously I'm already logged in the platform. So this is the aspect, the workspace of the platform. This is a cloud-based solution. And the idea of this platform, it's not only for storaging BIM projects, creating projects and collaborate with other people, but also the idea is to have like any professional network that you could imagine. We can also download and buy and download free applications or payment applications in the store, like any other application you could imagine, like Google Store or like Apple Store applications. Also, we can search for certification, professional certification like BIM Manager or any other certification that you imagine, lead certification, etc. There are entities of certification that are going to be here in the platform. Also, you can create your team members, your groups of projects in your contact list, also obviously in the platform. Obviously, we have also education purposes. For example, for universities, institutions, we can create educational projects for educational purposes, obviously. Also, we can search for job opportunities, like imagine like LinkedIn or like any other network for search for job opportunity. Imagine that you are a specialist in plumbing, for example, as today, and you are searching for job opportunities in order to search for open projects that are stored in the platform, and you can promote yourself like and specialized in any particular water system design or sanitary system design, and you can apply for these open projects. Also, if you are a promoter or a developer or a contractor, you can launch your offer for the different in order to search for MEP engineers, structural engineers in the platform for your local or your particular solution for your project. Okay, so there are many different purposes in order for like a professional network, in order to store BIM projects, to download or buy applications, for ask for certificates, professional certificates, create your contact list, your team members, educational purposes, etc. Okay, so let's see in the project tab. This is the main tab of the platform. We can see this is my project we have for the moment. You can see a huge variety, a vast sort of projects. So let's, for example, I'm going to open a project already developed with the different colleagues of my company. This is a Bauhaus school, for example, as you can see here. In this dashboard, you are going to see the 3D view of the project, as you can see here. And we can also see the management of the work team, which are included in the project activity, in order to manage the latest changes, the traceability of the project, which number of files are shared. Remember that we are talking about Open BIM technology. This Open BIM technology is based on open formats, standard formats that are not property of any software developers. We are going to share IFC files, GLTF files, DXF, XML, BC3, PDF, etc. All of standard formats that are going to do, that are not property of any software company developers, not even us or even other companies. And in this way, we are going to guarantee the durability of the project in time. So in the future, all of these files will be able to be opened with any software, any software tools that will be able to open these open formats. So in this, for example, I'm going to open this a little bit wider in order to see the 3D view. So in this here in this previous view, you can see the 3D architectural modeling, but we can activate for any other specialties. For example, we could activate the structures. Okay, structure is going to be, we are going to be able to see the beams, the piles, the foundations of this design. For example, we are also be able to, I'm going to activate another specialties depending on the project. For example, water supply installation, for example, and let's see, for example, lighting analysis. Okay, and we will be able to see in the platform the interoperability and the interchange of information between specialties in this platform. For example, here you can see, for example, these are the results of this project. Okay, for example, let's go back here and we are going to make transparency on the architectural modeling. For example, here. Okay, this is better to see. So in this view, you could see the results of the in 3D of the structure analysis, of the lighting analysis with these photometric curves of the different lighting fixtures. Also, we could see the water supply installation. For example, let's see here are the pipes. Okay, over here we could see the pipes, for example, here coming from this side, and obviously inside the building. If we're going to introduce inside the building, we will see obviously in the well rooms, obviously the piping of the system, cold water, hot water system, etc. Also, there are many tools here in order to establish, for example, sections, or in order to consult information with the different elements. So there are many possibilities here in order to see. Okay, so apart from, let's come back here to the project. Apart from consulting the 3D view, we could always also be able to see the files, the team members, also the warnings. This is the incidents and the interoperability in the different specialties, all the issues that have been developing in the project. When an issue becomes in the project generated by someone in a particular specialty, another one is going to be solving this issue, for example. Also the files, for example, let's go to the files, and here, for example, we could consult in lighting analysis the different results. For example, all the GLTF formats for the 3D view, sorry, and also for the calculation annex in PDF. Even directly from the platform, we could consult the results of the lighting analysis. So this is very useful because even for your clients, your customer, the developer, the contractor, or everyone involved in the project could consult the results in 3D and also the PDF, the drawings, the XF, the quantities, etc., directly from the platform. So you could consult the work team of the project and the modification history, all the changes, the traceability of the project. Obviously, we could attribute or assign roles in the platform, etc. Okay, so this is the idea, what we are going to reach in the projects tab of the platform. So let's just start with an example. And so I'm going to minimize here. So this is our software, our suite, main suite. And here we have, for example, I'm sure you have seen in the previous days, the previous seminars. For example, I'm going to start from a physical 3D model from IFC Builder. So I'm going to open the examples, and I'm going to open wherever a project of this tool, of this IFC Builder. Remember, IFC Builder is a 3D modeler in order to generate BIM models, IFC models, and it's a free modeler, so you can use it. Obviously, if you start or you collaborate with people that works with another BIM models of the market, like Revit, ArchiCAD, Allplan, etc., you could obviously start your work, your project directly from these applications. You don't have to start with IFC Builder. Okay, so for example, I'm going to open a residential building. Okay, this is a very simple building. here we can move with different floors. We can activate or deactivate the templates in 2D. This software that you have seen in the previous days, if we go and solve the 3D view, this is a very simple software and easy to use, very friendly. And here you have the different, well, also we could establish the shadows depending on the different orientation and the latitude of the building. Okay, we can consult and establish the shadows of the building. Okay, this is very useful in order for the performance, obviously for the energy performance analysis. Okay, this is very good. So here we could activate or deactivate layers, facades, work floor slab, etc. So this is the residential building in 3D, and this is the internal part. This is very simple. In order to generate this in IFC Builder, it's very simple. We work in 2D, but we raise the building in 3D. Okay. So we are going to generate a BIM project in order to communicate with the platform. Remember the Open BIM technology. So we are going to export here. We are going to link to a BIM project. Obviously, I'm logged in with my account, so I'm going to create a new project. For example, webinar site plan BIM. Okay. So in the professional, this is for example, other, because it's a webinar. We could be established visible for the platform in order to search for collaborations, only to my contacts list in order to create a team group, or not visible, for example, not visible and closed for collaborations. Okay, so this is the number of the project in the BIM side of the platform, and we are going to introduce here the reference of the 3D building. IFC building, we are going to export the templates to the platform. Obviously, we could generate quantities in BC3 format and standard formats for all the constructive elements here in the IFC builder. We are going to generate. One thing, while we are going to export and synchronize with the platform, in the store application, this is something I forgot to say. Here you can search for all applications, not only in the suite here, because the suite is very limited. Here we have many different applications, but obviously we are developing so many tools that this suite is the space is very limited. So we thought about introducing all the applications here. You could search for all the applications, or in the suite, or here in the platform. So for example, if we search by name, for example, site plumbing, okay, for site plumbing we have 4 applications. Today we have the idea is to see sanitary systems, site plumbing sanitary systems, okay, in order to see the site plumbing sanitary systems in order for full water and rainwater installations, okay, and also the site plumbing, water systems, okay. This is for water supply installations. But also you have, if you have time in order to check, for example, you have solar systems, site plumbing solar system, in order to design a solar thermal collector installations in order to provide for support for domestic hot water systems, or for heating or something like that. Okay, this is another tool that you have here. You can consult, you can download, you can try, test it if you want. So this is another tool you have. And finally, the other site plumbing tool is for schematic diagrams. This is a free tool that you can, if you have designed, for example, site plumbing water installations, you could use this tool in order to generate automatically a schematic diagram of your water supply installation design. Okay, so this is another thing you could also use. Okay, so let's come back here to the IFC builder. We have generated the IFC build. Let's check. Here we have the Synchroniser. This is obviously a free application that is allows us to communicate our tools with the platform. So here, this is the webinar I just created. As you can see here, webinar site plumbing. And let's check in the platform. Let's come back to the platform, home, or the home, the projects tab. Here we should have the webinar site plumbing. As you can see here, this is the project I just created. Obviously created by me. I have the role as like a BIM manager, and also like a specialist inside plumbing installations and sanitary installations, like as today I'm going to play that role. So webinar site plumbing, this is the 3D model generated by IFC Builder in this case, but this is an IFC file. You can see here, IFC file, a 3D file, a standard format. So I don't know if you are, for example, I'm going to invite other people to collaborate in the work team in order to generate the plumbing or the sanitary. Anyone don't have to know which applications, which tool has generated this IFC file. For me, it's only required a 3D model in order to calculate or analyze my specialty, my structure, MEP, or whatever specialty. For example, I'm going to, in order you to see, I'm going to invite a user, another one of my colleagues. For example, Vincent Castel. I'm going to invite him as the role. For example, I could attribute different roles. Here you have different help buttons in order to attribute different the permits you have as different roles. For example, as editor, okay? And the area is assigned, for example, he is going to design the lighting design and also, for example, fire protection, for example, because the plumbing, I'm going to do it myself, okay? So I'm going to add a message, Vincent, let's start the project, for example. And he is going to receive an invitation to collaborate and also this message in order to start the project we have been talking about to start this week, for example. Imagine, send invitation. Okay, so as you can see here, the operation is out. If anyone afterwards or during the presentation wants to be invited to the project, it's opened, or I'm going to change the project, and you can introduce the email, and you can be invited if you want, or at the end of the presentation, I could invite if anyone wants to introduce the email or share the email, and I will invite him or her at the end of the presentation. Okay, so let's move on, and we are going to start with the analysis applications. Okay, so we are going to the suite, and here in MEP tab, also you can search for remember, in the store you can download also and install individually these tools, site plumbing, water systems, and sanitary systems. But also in the suite, in the main suite of CYP, you have the site plumbing, sanitary systems, and water systems. Let's start, for example, for site plumbing, water systems. I remind you that this is a tool, an open BIM tool, focused on the design of water supply installations, okay, for any kind of building you could imagine, industrial, residential, hotel, school, etc. Okay, so I'm going to create a new project, plumbing design, for example. Okay, so I'm going to accept. I'm going to import a BIM model. All of these tools, site plumbing, water, and sanitary systems, you could also, if you click no, you could work as a standalone tool, only, for example, with templates in 2D, DXF or DWG, and make a quick design without a BIM model. It's possible also, okay? But normally, the main idea and the main target of this technology is to import a BIM model. Also, in order to see the 3D view, because it's very, very nice to see. So we are going to select the project. So I'm going to search in my list, project webinar site plumbing, accept, and click on next. So this wizard is going to guide us in the creation of the project. We are going to create a new water system installation, starting from this BIM model I have generated by IFC Builder. So the initiator, as you can see here, is IFC Builder, the residential building 3D. This is the IFC file. Here, normally it's just information in order for you to know, but it's not relevant. Where it's important for me now that I'm in the role of the specialist in plumbing, it's that we have a good IFC model, a good 3D model in order to make my analysis. So first of all, we are going to import to read the floors. I'm going to read all the floors of the building, as you can see, ground floor +5, okay, and the roof. Also, we have the room types, space types. We have different room types. For example, all the residential indoor residential space types, corridors for the common zones, and condition lit garage. We click on next. And finally, we are going to set the general settings of my calculations. So here we have different tools that you can manually introduce all the analysis option calculations, different criteria, general checks for your particular codes or regulations. Because another important thing of CYP is that we have implemented for the moment, if I'm not remember wrongly, it's on more than 150 codes implemented in our tools. So in this case, you could obviously create your material and equipment selection manually and all the design checks according to your regulations, but you could also import some predefined regulations. For example, for plumbing, for water supply installation, we have this regulation by default: Spanish, Brazilian, French, Italian, etc. We have also European codes or British standards or Portuguese, etc. So for example, today we are going to use British standards, okay? For example, one we are going to accept. Then the software is going to fulfill all the elements for material and equipment selection by default according to these codes. For example, for piping, we are going to use this medium density polyethylene water service pipe with this series of dimension properties, but you could also manage and customize it if you want, or add another different catalogs. For example, here we have these two manufacturers here, Aquatherm and Nueva Terrain also, but you could also create your own materials and equipment for pumping groups, for tanks, for storage tanks for water, domestic hot water, etc. What else? For design options, you could activate design criteria. You could, for domestic hot water demand criteria, etc. Okay, change the criterion design for the minimum diameter or the minimum available pressure, etc. The drawing options, you could also manage the color and the type of line for the different elements, the label, and symbols also. You could also even create your own symbols, personalized or customized with the different options here, okay? Even you could create your own symbols. For example, for consumptions, we have introduced by the regulations, by the British standards codes, these typologies of consumptions, okay? This is something interesting. For example, the consumption, we could create manually here with the different bulbs and the different mixers bulbs, but also this is interesting, and I forgot, maybe in the store application, you have the open BIM water equipment. I'm going to search by name. This is a free application in order to provide your architectural model, the bathroom fixed fittings, and the fixtures of your appliances of the bathroom. So you could also, that's a database by default that you could introduce all the fittings in your architectural design and export to the BIM project, and then communicate with the water supply and sanitary systems installations in order to provide the calculations, okay? So this is an intermediate step that you get in between the architectural phase design and the analysis, hydraulic analysis for water supply and sanitary systems. You could introduce the fittings if you want to export to the BIM project. This is a free application. You can download and use it if you want. In this case, today, we don't have time to see everything, but it's something I remember and it's interesting to comment. So let's imagine that the British standard by default, even you can customize or create manually, and you can create your manage your own libraries of presets of settings of calculations. So in this way, you can simulate any codes or any regulations all over the world for your own country if you want. Okay, so don't worry about it. Finished. Let's import the BIM model. So this is the information with number of files, which quantity of files we have read, documents, floors, spaces, appliances. In this case, there are no appliances for the bathrooms because we haven't developed the open BIM water equipment, as I said, and the electrical appliances in case we have developed for the other open BIM tools we have for electrical purposes. Okay, so the software is preparing the workspace, as you can see here. So this is the workspace. This is, I'm sure that rings you a bell according to the previous open BIM systems you have seen in the previous weeks. So here is the 3D view of our IFC architectural modeling. And here we have the different floors with the templates on the right and the different rooms. We could activate with the shortcut F4 of the keyboard, we have activate or deactivate. Even with these icons, you can activate or deactivate the different templates. So this is our design. So let's start designing quickly because we don't have so much time. So for example, I'm going to introduce, for example, the supply connection point. Sorry, I'm going to move on to the ground floor. Supply connection, for example. Let's imagine that the supply connection is here. So let's introduce a water pipe here. Sorry, I forgot to the thermal insulation. I'm going to introduce thermal insulation because even if we are not providing thermal insulation, it's mandatory in the software. Okay, thermal insulation. So for example, thermal conductivity for just up to 45 degrees, 0.04 thermal conductivity. We are just introducing some default value for the thermal insulation in order to avoid this phase. Okay, so don't worry about it. We are just always ready for listening to improvements, obviously. Okay, so this is the cold water horizontal pipe. In this software, you will always see these logs that are blocked or unblocked. So the log, it means that it's something that is going to be analyzed automatically by the software. If you block it, the software is not going to touch it, and you're going to maintain your criteria. So it's up to you. For example, the diameter, temperature, etc. Everything, all of this data is already taken by the software. If we are going to design automatically with this tool, because this software can check manually with the verification results with a calculator, or you can automatically design with this icon. Okay, so we are going to activate the flow. Is going to be taken with the different consumptions all of the network, so we are going not to touch anything here. So we are going to connect with this point that's up to here, for example, and up to here. So I'm going to check, for example, let's add a stop valve, a cold water, for example, at this point, in general, for the building, for example. And also, we are going to introduce a meter assembly here. Let's go to general settings and let's create a water meter assembly, for example. Assembly. Okay, so this is a meter assembly with a symbol. I'm going to provide this symbol, for example. If you want to force the local expressor plus calculation, you can do it if you want. So let's introduce this water meter assembly here in this. Sorry, I'm going to edit this element and just introduce, for example, the number of outlets. Let's imagine, for example, 4 outlets. I'm not going to, well, even I could, I could establish 8 and only introduce 1 dwelling or 2 dwellings as I wish. So horizontal pipe, cold water. Let's start from this point, for example, and we are going to, for example, up to here. And now I'm going to introduce a vertical pipe. Vertical pipe, cold water. Remember, I'm going to leave everything by default. So for example, for the 3D arrangement, this is important. You know, the initial elevation is going to be the ground floor. Just let's imagine, let's do the design of floor 3 dwelling, for example. So from initial elevation, here we are going to provide the vertical pipe. So this is the vertical pipe. Let's move on floor 1, 2, and 3 up to here. So here, a horizontal pipe, for example, and from this point just to the entry of the dwelling. For example, if we activate the template, we will see the different dwellings. Here is a dwelling on the right and another one on the left. So let's, in order to show you the example, I'm going to just design one dwelling, for example, and then I can copy from another floor, for example. So let's introduce a stop valve here, for example, and we could continue the design. For example, just for here, and just I'm going to design this bathroom, for example, and also the kitchen. Okay, the kitchen is here. Sorry. Okay. So, for example, in the kitchen, we are going to provide different consumptions. For example, the kitchen sink, it's here, and I'm going to rotate. This is the element, the valve, the mixture fitting valve. Also, we could add a dishwasher, for example, a washing machine with this orientation. Washing machine is going to be here, for example, and also a dishwasher here. Okay, perfect. So this is the fittings of the consumption of the kitchen. And in the bathroom, for example, in this bathroom, well, I'm going to move this to this point. Okay. Okay, I'm going to introduce the different consumptions. For example, water closet cistern here with this orientation, for example. Another one, for example, a bidet here. Also a wash basin here with this orientation. As you can see, it's very simple to use. And finally, the yes, the bath, for example, in this point here. Okay, so these are the consumptions on my dwelling. I'm not going to finish all the bathrooms and all the dwellings because we don't have time. So let's start with the design of the cold water horizontal pipe. Okay, so I'm going to start from here and I'm going to do this. And we could activate, for example, the ortho mode if you want. And here I'm going to follow the, let's deactivate here and just up to here. I'm going to connect to branch all the different elements to the distribution pipe here, for example. Okay. And also I'm going to do the same thing for the bathroom. For example, if I go to here, okay. And for example, from here, okay, here, and finally this point. Okay, so this is the distribution of the cold water pipe. Let's introduce, for example, what else can we do here? Obviously the hot water. How we can generate the hot water? For example, we have to introduce the hot water production. A water heater, for example, of 80 liters, for example, we could introduce these elements in the kitchen, for example, here. So let's connect the different pipes. So here, cold water pipe to the distribution pipe. And we are going to generate now, sorry, the hot water distribution pipe. From here, I'm going to generate in parallel to the cold water distribution. Okay, so let's here just to the different wet rooms that we have in the job. So for example, here, just up to here, for example, and connect to this point, and finally, obviously, in this element. Let's deactivate the ortho mode and connect. Okay, perfect. So here we have left the kitchen, for example. Let's activate again the ortho mode. Okay. Let's connect here. And finally, the kitchen sink. The dishwasher and the washing machine are already connected. And finally, here. Okay, perfect. So let's say from time to time, we can manage the automatic saving times or registered times for the job. So more or less, I think, well, we don't have to, we could have the possibility to design the hot water return production, but not in this case. So we could also generate, for example, wet room valves in the general settings. I'm going to do it quickly. For example, wet room valve, and I'm going to activate the wet room valves. Okay. For example, sorry, the manifolds. This is something mandatory. Okay. So wet room valves. So let's move on and introduce here the wet room valves. I have to introduce one for the cold water here, for example, another one in the bathroom here, and finally we are going to develop design for the hot water. Let's introduce another one, a wet room valve for the hot water design. Perfect. So accessories, hot water, wet room valve, finally, in order to cut the flow in the kitchen and in the bathroom. Sorry, it's here. Okay, perfect. So we saved the changes. I think everything is more or less designed. Obviously, we haven't finished the building, but we could also, at this point, we could design automatically or verify the results. If we automatically design, so for example, the software is going to try to analyze the whole job. For example, if it's something wrong, the software should tell us. For example, in this case, according to these regulations, and according to this material, we have the continuity. We are not verifying the continuity here for this diameter. For example, we consult the checks, we could see the details. So this is, at this point, we fail. So we could obviously activate automatically, but we don't comply the velocity. So we have to see the different results. So at this point, we have to see if it's a problem of the materials available in the job, of the regulation calculations, according to the simultaneity, for example, the criteria, the continuity criteria, or something like that. This is something with time we could also solve. What else can we do? See the 3D view. Well, in the floor 3, we could see the results. In this point, well, we have the same problem of the continuity criteria here. Okay. We could consult the results, gross flow, consumption, simultaneity, etc. Okay, of the different elements and points, and we could activate and see the results of each piece of pipe in the calculations. If you go to the 3D view, we will see deactivating a little bit. As you can see here, we have the piping. Let's move on. This is in a cable, in a single line representation. Let's change it to the single filament to the real representation of the diameter. So you can see here, we start from the ground floor, we pass through the check valve, the stop valve, the water meter assembly, and finally we have this representation of the calculations here. Okay, of the different piping. So here we could also get an animation of the flow with the real velocity. This is very good, very nice, in order to see the real velocity of the piping, because it's something that we provide us for the designer. If something wrongly designed with a extremely high deep velocity or a low velocity, we could change diameters or criteria of calculation. Also, for example, here is in the floor. For example, as you can see here, it's in the floor, but what about changing the design for the ceiling? As you can see here, all the piping are in the floor, but what about changing the design for the ceiling? For example, 2.50 height of the installation, and let's design again. If we redesign to the 3D view, we will see the representation in the ceiling. You can see here with the animation of the flow in the ceiling of the floor 3 and go down. The software provides automatically this piping, this vertical piping, in order to according to the consumption. This is a single representation because we don't have the fittings, so don't worry about it. If we had designed the open beam water equipment, we could see the fittings here. So this is very simple. Okay. Also, you have many tools. For example, you have many tools to do symmetry, to copy from another floor. For example, I'm going to do it quickly. Okay, For example, let's copy in the floor 4, for example. Let's go copy another floor plan, for example. Here, copy all the elements from this point. Okay, copy to the floor 4. Okay, so here in the floor 4, we have the design. So I'm going to move a little bit this pipe. I'm going to go to the ground floor. As you can see, it's very, very simple to use. Cold water, horizontal pipe. Let's go here, from here, just up to here, and introduce another vertical pipe, cold water pipe, in order from the ground floor to the floor 4. Accept and introduce here. So if we go to the floor 4, we will see the reference of the vertical pipe. So here at this point, I can move this pipe and connect it to this vertical. Okay. If I edit here the height of the installation, 2.50. So I save the changes and design again. If everything is properly designed, you will see, as you can see, because the dwellings are already the same, we have the same design with 2 pipings, 2 vertical pipings that coming from the metal assembly in the ground floor, as you can see here. Okay, so this is very, very simple, and as you have seen another way of copying from the different floors. Okay, so this is it, and in the animation we could see well, the flow of the different workflow from the metal assembly to the different floors. Okay, okay. So what results we could obtain here? So if we go to the documents, we could generate a project, complete project. For example, project water supply. Okay, so let's activate the design criteria, result checks, materials, for example. We will see in a minute the bill of quantities. So in the documents, we will see the project water supply. Sorry. Here we have the design criteria. Here with the results, all the theoretical calculations here. Okay. Project water supply with all the results, all the calculations. This is very nice. All reports in CYP tools, you can export in different formats, docx, PDF, TXT, HTML, etc. Also, you can share it with a colleague, with your client, with your developer or your team member colleagues in PDF via our server PDF, or you can print it in paper and PDF as you wish. So this is export result. The results export in different formats is very, very useful. Okay, so the drawings, also apart from the reports, we could generate the drawings in DXF or DWG with all the elements. We could deactivate the DXF. For example, let's only represent the floor 3 and the ground floor because it's only the floors I have designed. You could generate the drawings in DXF, DWG to your CAD software in order to customize it in PDF or in paper directly. You can add a title block, layers, generate the layers, the reference of the layers and the color if you want. And we will finally generate these drawings. This is also very good because we have all the calculations. Obviously, we could activate the results you want to represent according to the pipes. And also we could manage the text. Here in the reference, we have a legend here with the symbols and all the elements introduced here and the calculations. In the ground floor, also we have the legends and the elements. Okay, all the drawing options are customizable by the user. Remember here, I'm going to analyze here and cancel here, and the drawing selection, the type of line and color, the label, and which elements you want, if you want the length, the reference, diameter, etc. So this is very good also. I haven't talked about the units. The units, I'm working in international system, but if you want to IP system, you can manage, or you can manage individually. For example, for the pressure, if you want, instead of metal water column, you will prefer to work in PSI or in bars, Pascal, you can manage, even the accuracy of the general units. Okay, everything is customizable by the user. Okay, so this is it. So we are going to export. Another thing interesting is the results in the graphical analysis, for example, for the velocity or the pressure losses. Even in 2D, you can see the pressure losses with this scale range, okay, even in the ground floor. Also, we could see for example, for the flow, the different flow elements in the different pipes, okay? Also in the 3D, we could result this graphical representation of the flow, the velocity, whatever graphical analysis you want to represent, okay? So let's export the results to the BIM project. Yes, going to represent the reports, the drawings, and we are going to accept. So finally, what we have left, and this is a very, very recent novelty of the 2020.e version. Sorry. DXF. Okay. So I'm going to exporting the results to the BIM platform. Remember the workflow we have been talking about in the beginning about the technology. Remember this technology. All the technical documents we are generating with the specialist application is going to return to the BIM project. Okay, so this is important. So apart from the results of reports, drawings, and the IFC results to the BIM project, we have this tab. This is very recent from this version, from the 2020.e version. So this is the first stage generation of the quantities, but this is very good and this is a powerful utility. So the idea is, first of all, well, we can establish the general data. For example, we could actually generate the bill of quantities in euros, for example, or in dollars, or whatever currency. The idea is to have a database in the future for different currencies. You could manage the decimals and the percentage for contingencies, taxes, industrial profits, etc. All the taxes or the extra percentage that we have in the material execution budget we want to provide. So the idea of with this tab, we have closed the loop, and we're not only able to generate the results in reports and document in drawings, but also the quantities and the prices. So we are going to generate the general data, and we could in the price banks. Here, for the moment, we have this price bank. It's in Spanish because we are a Spanish-based company, so our headquarters are in Spain. So for the moment, the first version, we have this price bank in Spanish, sorry. But also, you could create your own database of your own price banks manually. With this icon, you could all generate manually, or you could import from VC3 files. Also, obviously, if you have your databases for the different countries you work with, and also in the future, if you have your databases in different formats, you can talk to us, and we could talk and introduce these databases, these price banks, in the software. So don't worry about it. We could able to generate it. But if you have the files in different formats, you could import your price banks. Okay, so you can create manually. You have used the Spanish database for the moment, introduce manually, or import it from your standard formats from the price banks. Okay, or in the future we could provide your price banks here. Okay, so apart from establishing the price banks here, loading from a standard formats, creating manually, or introducing from this Spanish price bank, we have to establish the mapping. Okay, this mapping. This is very important. Here we have the plumbing, for example. This is by default in the plumbing or mapping files we have created. I have created in different files before. For example, in another software. Here you can create your own mapping files with an empty structure, and you can create your own structure of chapters of typologies of elements. job units, etc., job items, the spine structure, or the OmniClass for international structure. So you have different mapping structure files. For example, I have created with the structural OmniClass files, I have created these elements. So I can use it, for example, these mapping files. So once I have the mapping files created manually or using the ones you have over there, you can update the quantities. So I'm going to update it. Just update the current budget with the plumbing mapping and the price bank we are going to generate. For example, in this case, in order to simplify, I'm going to use the Spanish price bank. Okay, I'm going to accept, and the software is going to provide automatically the mapping structure according to this mapping file. I have used it, as you can see here. This is the OmniClass plumbing services. We have different elements. Okay. In the mapping file, we have all the classification of the elements introduced in the software. And for example, normally they are already attributed because I have worked in previous works. But for example, here, the fixtures, for example, we don't have price here in this database, in the Spanish database. But we could establish by default, or we could set it without price. But we can provide the different elements. For example, well-room valve. I'm going to search for the valves. Here, sorry if they're in Spanish, I'm going to search it. For example, whatever valves here, this one, I'm going to assign these codes from the Spanish price bank. I'm going to assign to the codes of the cold water well-room valve. I'm going to assign over there, the same one. That is not important. The water heater, for example, another. I'm going to search for the water heaters here. For example, these ones, electrical thermal water heater, for example, I'm going to assign here to the codes of my mapping file. What else? The bath fittings, we don't have a price, we don't have any database here. And finally, another valve for the well-room valve, for example, this one, I'm going to assign. And the water meter assembly, in this case, I think there are in this database, yes, we have this battery, this meter assembly for different number of outlets. So I'm going to attribute it. So what else do we have to get? The work section, according to the structure of the mapping file, we have here, I'm going to copy and attribute to the same chapter in order to simplify. So I copy here, I paste here, and introduce. Okay, so this is it. So aside from the water fixtures or the bathroom fixtures appliances, we don't have price or database in this data price bank. We are going to accept, and the software is going to automatically introduce all the bill of quantities. So here you have the bill of quantities summary with the expenses and the material execution budget of the materials. This is in euros, but we could establish another currency. This is very, very good. For example, let's go to the piping, for example. This piping with the horizontal pipe, we have all the measurements here, all the quantities here. This is for this one, we have the price and we have the total. Let's go to another piping, for example, for the vertical piping here, we have the measurements, this 12 meters with this price and the total expenses, the total amount. So this is the idea. And even if you, I don't know if you can see it here in the 3D view, even when I double click here, it's going to be highlighted in the 3D view. So this is this pipe. If I double click in this other one, this is going to give me, lead me to this job item in my bill of quantities. Did you see? Can you see it? I don't know if it's highlighted in like an orange color. Okay, this is for this pipe. If I go to, for example, the water heater, if I double click here, it's going to provide this water heater, 80 liters, 2 units, and this price for each one. So this is it. This is the idea. Okay, so this is the idea of the bill of quantities. It's very good, and you have also the bill of quantities and bill of material execution plan. So if I export again to the results, we could export also the quantities to the project. And this is a very, very good, really powerful utility of functionality of the bill of quantities and bill of materials result with the price and all the details for the execution material execution budget for this plumbing water design. I'm going to export again, and the Synchroniser is going to generate the results. If I open this Synchroniser, in just in a few seconds, it's going to export the results for the webinar site planning. As you can see here, it's exporting the results to the BIM project. If I come back here to the platform, we will see in the project tabs, webinar site planning, as you can see here, files, we have the water supply installation project. Remember, apart from the 3D building architectural modeling with the templates, we have the water supply installation design with all the templates, all the takeoff in VC3 formats, and all the results in the PDF elements. Okay, all the materials, checks, results, design criteria of the PDF result. This is a very, very good results document for the water supply installation. Also in the 3D view, obviously, we can go into the dashboard. I'm going to just see a little bit wider this design. I'm going to, for example, make transparency on the design and activate the water supply. And in this case, here, obviously, we could see the design of the different elements. Even here, I can click on any pipe and see the different information, the horizontal pipe with the diameter, the length, etc., which is designed by our software. Also, I could activate the animation here with the overflow. As you can see, the water flow in the horizon in the view of the platform. So here we could see all the water flow in the piping, in the vertical pipes, and each horizontal pipe. Also in the supply connection, as you can, sorry, I'm not very, because of this mouse. Okay, so this is the animation. So this is the idea of the workflow. Okay, if I double click here, I can see the supply connection material with the diameter, go water, and the length. Okay, so this is it. Well, let's do it the same thing, and in order to finish the webinar with the sanitary systems. Okay, I'm going to site plan and sanitary system. I'm going to be really a little bit faster because it's the same thing, but instead of talking about water supply installation, we are talking about full water and rainwater installations, drainage system. Okay, so I'm going to create a new design, webinar sanitary. Okay, design, we are going to accept. This is the same thing, import a BIM model. But in this case, we are going to read not only the architectural modeling, but also the water supply installation in order to just to see in the 3D view in order to avoid interferences or clashes in this design phase. Now I'm going to click on next. Okay, this is the wizard. It's going to guide us in the process of importing the BIM model. Okay, so this is the 3D modeling, architectural modeling. We are going to activate also the additional file, which is the design of site planning water installation. Finished. And we are going to start the process of importing the floors. This is the same thing, the pricing, the room types, and we are going to the same thing, the design check options, the material and web installation. You could simulate any regulations all over the world you could imagine for your country, your local authorities, or whatever regulations codes you use. Also manually, you could introduce manually all the criteria and manage your own libraries, but you could start from and afterwards customize it if you want. For example, I'm going to use according to this preset, default codes, I'm going to use, for example, the European or British and European codes. We are going to accept. All the elements are already charged and loaded in the software. We are going to finish, and we are going to use this European codes by default for this sanitary design. Okay, we accept, and we have read all these files because we have architectural and water supply installation files, spaces, and the software is going to prepare the workspace environment. So as you can see here, really the software are very similar. The water supply, the site plumbing water systems and sanitary systems are really the same. So once you could be able to manage one, the other one is more or less the same. Okay, so we have the 3D view here. Also in the layers, we could activate the water supply, and not only the architectural modeling, but also the water supply installation here. Okay. And we have the number of floors and groups of the building with the templates. We could activate or deactivate whatever point in the results in the working with the software. And now we are prepared to start introducing the elements. The same thing that we have done with the water supply installation. For example, we could go to floor 3, for example, this dwelling. Let's start, because we don't have the fittings, we have the template in order to, for example, in this case, I'm going to do this bathroom, for example, bathroom 1 of this dwelling in the floor 3. So let's start with the discharges. We have the wash basin, for example, for this case, more or less. Also, we have the bidet here, and finally the the toilet with this tester. Okay, so after that, we are going to, for example, we are going to provide or introduce the vertical pipe. The order of introduction of the elements, it's according to your criteria, your preferences. Okay, it's not mandatory to start from the piping first and afterwards the consumptions. Normally, I prefer to establish in the sanitary systems, normally prefer to establish first of all the consumptions and afterwards the piping, the vertical and the horizontal piping. Okay. Full water drain pipe connection, and I'm going to provide the vertical here according to the template. The initial elevation is going to be the roof to the ground floor. Perfect. So now we are going to provide a horizontal pipe, discharge connection for the full water. Even there are many options in order to establish by default elements. So this is going to be, for example, the toilet is going to be over here, for example, and we could activate, for example, a discharge connection here and another one over here, for example. I'm going to move this point here. So now I'm going to make a main drainage pipe from this point to this point, for example, and finally just to the connection of the vertical pipe. And this point is going to move from the toilet to this point. Okay, more or less. We could do the same with another bathroom, for example, or even the kitchen. For example, if you want, I'm going to do it in the kitchen. For example, the church's kitchen sink. Okay, for example, here. Also the dishwasher. Here, more or less, it was here, and the washing machine. Okay, so horizontal pipe. Let's go to discharge connection, for example, from this point to this point, another one from this to this point, and finally this kitchen to this point. Okay, horizontal pipe, main drainage pipe for water from this point to this point, and finally we are going to provide the vertical pipe for water from the roof to the ground floor. Okay, perfect. Finally, horizontal pipe, main drainage pipe. This is a collector pipe which is going to connect to the vertical pipe. Okay, perfect. So let's connect in the vertical pipe what we have left. In the roof, we have to ensure the ventilation, the primary ventilation. So we have to provide an air vent here for the full water, an air vent here in order to finish my vertical piping, my downspout. Okay. And finally, in the ground floor, we are going to collect this full water, this one and this one, in order to connect to the different, maybe imagine expansion boxes or cleanouts, in order to collect to reach the supply connection outside the building. Full water drain pipe, for example, from this point. Okay, I connect here, for example, imagine up to here. And from this another vertical pipe from this point to this point. And at this point, we are going to install or place an inspection box, a full water shallow inspection box. And I'm going to place it here. So once we have it here, I'm going to, move this point to this face of the inspection box, another one here. And finally, the exit or the outlet drainage pipe from the inspection box from here just to the public network, for example, here. Supply connection point, full water, and finally here. For the different elements, obviously, we have the same thing. This lock or blocked or unblocked, in order to, the software is going to analyze automatically all the elements. But if you want to force, for example, the elevations, all the different slopes, because you have some requirements according to the different buildings, so you can block it, or the diameter, because this is a part of the installation is already installed, you can do it. So let's save the changes and automatically design. So there are no mistakes, it seems, or maybe something worked. Some warnings. The minimum free height, of course. The minimum free height of the building. This is some check by default activated here. If you don't want to activate, you can unblock it. But normally in the floor 2, I'm going to edit here and decrease the minimum free height. For example, 2.50. Imagine that we have a 2.40 free height building in each floor, so the warnings disappear. So let's go to the 3D view and see this thing. Well, for example, deactivate the 3D building. So here we have, on one side, we have the water supply installation, and on the other side, we have this sanitary systems installations, as you can see here. Okay, this is the sanitary system installation. This is the bathroom on one side with the vertical pipe, and here we have the different elements to the public network. Okay, and also here we could animate the animations to the workflow. Let's deactivate the water supply and the ground, and if you see the water supply, the sanitary system animation workflow. As you can see, the velocity is a real representation. This is by gravity, obviously it's very quickly, and here is slower. Okay, it's clear. And here, for example, you can consult information for the different pipes, generate patch grain 45 degrees, properties for the different elements. Okay, this is it. Finally, for the rainwater, for example, for the rainwater, we have to establish the rainfall intensity. For example, imagine according to the import configuration rainfall intensity, let's imagine this factor. Let's imagine this is London, for example, I don't know, in order to say anything. We accept here, and in order to collect these rainwater installations, this is a sloped cover or sloped slab, as you can see here in the top of the building. So we are going to provide, first of all, a drainage area, rainwater area, and we are going to collect this rainwater with a gutter. Okay, so we are going to more or less create a drainage area at this slope, as you can see here in the 3D view, and we are going to provide, for example, a gutter. Well, first of all, we could establish the vertical pipes, for example, rainwater, vertical pipes, and let's introduce, for example, at this point, let's imagine one over here and another one over here. I'm going to connect now the gutter, and from this point to this side of the vertical pipe. For example, from this point to with this slope. Sorry, I'm going to move this a little bit realistic. And another gutter here from this point to this side. And finally, from this point to this one. Okay, voila. So let's move on to the ground floor and collect these rainwater vertical pipes. So, sorry, horizontal pipe, rainwater, and if we collect from here, let's imagine up to here, and from this point to this point. Let's introduce an inspection box for rainwater. We could establish here and move the connections to the different sides of this suspension box. And finally, a horizontal pipe, a drainage pipe for the outlet of the suspension box to the public network. In this case, sorry, we have designed, better said, a separative rainwater and full water installations with two connections with the different public networks, one for the rainwater and one for the full water. Obviously, the software allows you to provide mixed full water and rainwater system. Okay, so let's save the changes and design. Okay, so in the 3D view, we will see if we activate the 3D view. Well, this is something wrong, I have said, because obviously the gutter is obviously flying over the building. So let's move it to the roof and let's change the position of the, if I don't remember wrongly, so 2.5 more or less, minus 2.5, and then block the height. For example, minus 2.5. And finally here. And we force, we block. If we analyze again and we go to the 3D view, we will see just the position is much more realistic. We could activate the flow of the rainwater also. Okay, this is it. So the results, well, the bill of quantities, I'm not going to do it, is the same process, the same methodology we have introduced the mapping and the price bank in the water supply installation. It's the same. So I'm not going to do it now. I'm going to show you the reports. For example, project Sanitary, for example. I'm going to introduce the results for the wastewater and the rainwater results. In this case, the bill of quantities, we don't have time to do it. And the documents, this is it. This is the project Sanitary with all the criteria, results, with all the verifications, the gutter, etc. This is very, very detailed with the different rainwater, design criteria, wastewater network, etc. You could also share export via different formats, as we said before in the water supply installations. And finally, the drawings. The drawings is the same thing, the same process. For example, here we are going to activate the show DXF in the floor 3, for example, roof and the ground floor. Detail of the drawings. This is the rainwater installation of the roof. The floor 3 of our dwelling, we have designed as an example with the legend of the symbols and the discharges with the different diameters, and the network which it belongs each element, and the ground floor with the different inspection boxes and the symbols and the legends. Here we could print and generate the files locally if we want. So if we export the results, finally, in order to close the loop, reports and drawings to the BIM project. We could do the same. Well, the floor. Okay. Perfect. So in the BIM project, we will see the synchronization, obviously, of the IFC results and the reports of the sanitary installation. Let's update it. Voila. Wastewater installation project. Here we have all the drawings, the except for DWG format, CLTF, the PDF project sanitary results, documentation of our design. Okay. And the GLTF results in the dashboard. And in order to close the presentation, we are going to get wider this site plumbing design. And we could, for example, make transparency or make transparent the architectural modeling and see both designs in the 3D view. This is also, for example, we could establish, for example, different sections for the elements, even, okay, for the different designs, if you want to see the results. And also we could, for the wastewater installation, we could get the animation of the wastewater design. Okay. But if you prefer, I'm going to make invisible the architectural design. And let's activate, also animate the water supply installation. Okay. So this is it. Okay. So, well, I think that, I don't know if it's clear, from my part, from my own, I think I finished with the webinar. So more or less the idea today was to introduce a little bit more the BIM workflow and introduce the site plumbing solutions for for water supply installations and for rainwater and wastewater installations. So now, if you have any questions, any queries about the webinar, you could write it on the chat, and I will try to answer the questions. But if you any questions that could come to your mind after the presentation, don't worry. I'm going to give our technical support address. So this is the technical support address, support@site.com. If after the seminar of the webinar, if you're going to test it, to try it, or to make a real presentation, or a real installation, so you could also ask the questions or queries that you want. Okay, so Mr. Ross, yes, well, the presentation is being recorded, so don't worry. Afterwards, we will be able, my colleague Vincent could send you a link in order to download it or to watch it calmly after the presentation. So don't worry about it, that we will be able to send you the links to consult to see the webinar calmly afterwards. Don't worry. Yes, it's possible. Any other questions? Any other queries? Any other feedback do you want to share with us about the water supply installations, about these site plumbing solutions? Did you find it interesting or useful for your country or for your local codes, for your codes of any feedback would be very welcome. Okay, thank you very much. Mr. Khan, for your feedback about useful in India for Mumbai. Thank you very much. It's nice to hear it. Okay, so another question about the support for pipes. I imagine you, I imagine you remember pipes for overall for water supply and for drainage, also for drinking water. Not for the moment. We are talking with different manufacturers, with different vendors, suppliers, in order to provide an open BIM system for that purpose, for the supports of the piping. This is a good suggestion. We are in mind of it. We are talking about with different manufacturers. We hope that in the future we have these supports for the piping, not only for. I imagine overall for the. I find it interesting for the rainwater or the the full water installation. But yes, this is something we have in mind, and I hope that in the future we have some open BIM system for that purpose. Any other questions, queries? Thank you, Mrs. Kanti, for the feedback. Thank you very much, Mr. Nagapan, for the questions. We take notes. We note. We have in mind all the suggestions, all the comments and feedback of your part. So in the future, so in order to improve it. So this is very, very welcome. I encourage all of you guys to, in order to test it, to try to make a real project that you have. This is the real part that maybe you can take benefits of the software and to see how to use it. So this is the idea, and I encourage you to test it. Any other comments, queries, or any other questions about the use of the software, or about any other things that you come to your mind? Meanwhile, we are showing you some projects that we have in our platform that we collaborate with the different colleagues in the department. No comments, no further questions. Well, so I think that for today it's enough. Thank you very much for your attendance today to today's webinar for the site plumbing solutions. I encourage you to remember the both tools we have seen. In order to summarize a little bit the webinar, we have seen site plumbing water systems, site plumbing sanitary systems, in order to design water supply installations and sanitary systems. We have also the open BIM water equipment in order to provide the appliances, the bathroom fittings in the buildings. Also, we have used IFC Builder in order to generate the BIM model, but you could use any other ArchiCAD, Revit, Allplan models in order to communicate with our design tools. And also, you have site plumbing solar systems if you want to design solar thermal installations to domestic hot water support or heating support. Or finally, also you have the site plumbing schematic diagrams in order to design, apart from starting from the water supply design, your schematic diagram of your water supply site. So thank you very much for your attendance, your patience, and I hope you see you next week, that we have fire hydraulic systems and fire protection design. So thank you very much for your attendance. See you next week. Thank you very much. Bye-bye and have a nice day.